Hi, good afternoon. I'm Deodato Tapete from the Scientific Research Unit at the Italian Space Agency. I will present today this joint presentation. Actually, it will be only myself, but the presentation contains elements from both of us. Over the past decade, we have been working in different organizations and now at the Italian Space Agency on the use of satellite imagery to monitoring the structural instability or stability of buildings, hopefully. Also to develop methodology to support end users to plan better the interventions and the maintenance works, giving also the constraints they may have with available funding. So the technology I'm going to present today is something that should help heritage bodies, either public or private, site managers, who are in charge of the conservation and planning of maintenance works of historical buildings in historic cities, but also archaeological ruins and sites and monuments. In their ordinary duty, typically, these end users have to basically decide whether to invest among the various and sometimes overwhelming bulk of historical buildings, where to invest their money, to intervene where it's a priority and it's absolutely needed. This poses, of course, some challenges because you have also to work at different scales. So, for instance, in our historic cities that are fully packed of buildings, monuments, they have to know not only the specific weaknesses of individual buildings, but also how they contextualize within maybe some general patterns of instability. They have to repeat this assessment, so they need updated data. So we can provide them with some information that jointly with other information, and I'm going to present a use case in detail, they can basically prioritize. The technology is called satellite radar interferometry. Probably you know that there are several space missions acquiring in the microwave domain since the early 90s across the whole globe. And they basically provide images of the Earth with a very regular schedule acquisition. And basically, they can provide us a way to measure the deformation at the surface, and in case of buildings, their own position every time the satellite passes over these buildings. So in reality, we are able to monitor buildings, infrastructure, man-made objects that are recognizable every time an image is acquired to obtain plots like the one that I've presented now in this slide, showing every time the satellite passes the exact position and millimeter precision of the buildings. So we can basically measure, for instance, the impact of earthquakes, but also the impact of ground motions due to landslides or slope instabilities, or land subsidence in areas like growing cities where we have overexploitation of groundwater resources, and a consequence sometimes is land subsidence causing collapses and structural instability. Last year, with my colleague Francesca, we have done basically a map of the current state of the art of the studies, where basically researchers and end users have used this technology to understand the value of this satellite data to monitor the ground instability due to landslides or earthquakes or volcanic activity across the whole UNESCO World Heritage Sites of Europe and beyond. And as you can see from the map, Italy is one of the countries which is mostly populated with several studies, and you can clearly identify hotspots with several studies undertaken, and not surprisingly, over historic cities like Venice, Rome, Naples, and many others. One of the earliest experiences, which nowadays could act as an interesting use case, was done in Rome. Basically, in 2009, the Italian government nominated a commissioner to undertake some urgent measures to intervene to the conservation of historical buildings in the center of Rome. Rome is a perfect example of historic cities where basically we have a very high density of monuments requiring maintenance and surveillance of their structural health. And at that time, there were several different incidents. In 2010 also, on the Oppian Hill, just in front of the Colosseum, where a huge collapse occurred. So in that case, the Italian National Department of Civil Protection, the Italian Ministry of Cultural Heritage and Activities, and the state and municipal superintendencies basically made a joint effort to use also the most developed technologies from space, jointly with other type of investigations, to understand where exactly they needed to intervene the most. And the University of Florence has a department dedicated to earth sciences and acts as the center of competence for the Italian National Department of Civil Protection. I was involved in this project at that time when I was working there, and the Department of Earth Sciences led this project to basically favor the technological transfer of this technology to the end users, providing a space view of something that they were already aware of, but they needed also a further evidence supporting their planning and decision-making process. So at that time, the satellite monitoring solution that we deployed was basically to use all the available satellites, either already closed missions providing archive data and ongoing missions still acquiring at that time, to basically map three different scenarios. Monuments which were partially exposed along the steep slopes of the Seven Hills of Rome, and in particular the Palatine Hill, that were tilting due to the effect of the load of the terrain behind. Second scenario, motions at the surface, which are actually proxies of inner instabilities of buried and underground infrastructure or old buildings that are basically collapsing. And the third scenario was about the exposed ruins collapsing or subsiding due to ground motions. I'm just quoting here directly from the final report of this project that was edited by the commissioner nominated during that emergency. I have just reported records, all the Italian sentences, but just to point out that the measurements I'm going to present now, for some examples, were fully embedded in the decision-making process. And they were part of other investigations, either from ground observations that typically technicians of these end users do in their daily activity, and also other technologies like LiDAR or GPS. And they were all integrated to basically substantiate the condition assessment reports made by these officials, also to support the justification for investment. So we ended up with this map of conservation criticalities. Speaking in terms of space-based products, this could be classified as a level 3 product, actually, because it's a map where at the top you see how these measurements are usually showed to the end users as points, providing you the information of the average velocity associated also with the full time series of displacements. But we went beyond that, and we combined this information showing which buildings were moving from past to those times, with the geological hazard susceptibility already mapped and the history of conservation of these buildings. We ended up to map exactly areas that, based on the satellite measurements, could be considered high priority. One case, in the southwest portion of the Palatine Hill, we identified an area which was persistently moving since the early 90s throughout the first decade of the 21st century. And in that case, we could support the hypothesis of the archaeologists and architects that were quite concerned about the instability of this sector. So this was one of the key areas where they basically decided to invest the money they had during this emergency. But sometimes satellites also can show good things because this area was already maintained by the local superintendents. The problem was mostly that it was a huge effort across the whole archaeological area to intervene timely. So where they actually did already at that time restoration and consolidation works, satellites provided an objective evidence that those restoration interventions were good. Because if you see in this case, the Domus Tiberiana is one of the first scenario case studies I was mentioning before. Is a partially exposed archaeological ruin, but it suffers from the load of the terrain behind, and in the past, in the 90s, it was moving. This was assessed by the local officials with GPS measurements, and based on that, they did a restoration and consolidation with the partial reconstruction of the arcades. With our data, not only we supported the back analysis of the ground instability motions that led these officials to justify an intervention, but also to prove that afterwards the condition of the monument was definitely improved. So this technology can be used also to observe afterwards of the maintenance works if everything is going as planned. In Italy, we are pretty lucky, I would say, because the Italian Space Agency, in addition to the available European Space Agency missions, has its own mission called Cosmos SkyMed, which, by the way, is one of the contributing missions of the Copernicus program. And we have this project, Map Italy, who's basically acquiring routinely, every 16 days, the whole country. So there's plenty of opportunities to continue monitoring the health of these historic centers. And we did that with our colleagues from the National Council, National Research Council of Italy, and I see someone in the audience. We did a few years ago this study just to prove the concept. Having routinely acquiring data from space, we can basically update across the whole extent of the historic center the condition of this monument. I just reported here some of the examples, and we can, of course, intersect this information with information that we receive, for instance, from ISPRA, our geological survey, who provides us with the information of the geological susceptibility, and we can identify areas of major concern. I'm just closing my presentation to say that during that study that we did last year, we observed, that, and this is just only from the research side of the publications, that basically, as soon as data from space, from new missions are available, because this is a technology already regarded by the researcher community, but also the user community, these data are already used to feed into the process of the decision making. Thank you for your attention.
Well, thank you, Deodato.